Alright, I'm going to go ahead and look at another method some people call a little shortcut for integration by parts, and it's called the tabular method. So let's go back to, in the previous one, the example I started with is integral of x e to the x dx. I want to do that one again using the tabular method just to show it'll get you the same result. For this one, it really doesn't make it that much shorter. It's more when you get into the thing, which we didn't look at in the last one, I saved it for the tabular method, when we have values of x that are like higher degree than 1, so x squared, x cubed, then it does save some time. And it probably makes it a little easier not to make mistakes like sign errors and stuff. So what you do for your tabular method, you have 3 columns here. One is the sign. Okay, the next one is your u, and then the last one is your dv. Alright? So, what we're going to put here in the sign, it always starts with a plus, and then it's just going to alternate as long as you go. And then for u, you're going to put whatever you would choose for u, just like you would in the other method. So in this case it would be x. For your dv, you put what the rest of it is, so in this case it would be e to the x. And what you do, you're going to go ahead and take the derivative of u until it becomes 0. Okay? So it'll be 1 and then 0 in this case. So it's real quick. Again, this isn't going to save too much time for us because it's a fairly simple one. And then, so then let's fill in the rest of the chart with this e to the x. So this is pretty simple. The antiderivative of e to the x is e to the x. Antiderivative of e to the x is e to the x. You just continue to take the antiderivative of each one till the end. And you'll see in the next one if you're confused, I think, what's going on. Then these signs just alternate until you get to the end. And this is how it works, okay? You kind of connect them in this fashion right here. So the sign will tell you, okay, you go to this one. Well, it doesn't tell you which one you go to. You go straight across to the u, and then down to the dv. And then go down to the next one, straight across, and down. And then you're done. You don't go to the last 0. Okay? So what this tells me is, okay, my answer is going to be, it's positive x times e to the x, so x, e to the x, and then a negative tells me, okay, it's negative 1 times e to the x, so it's going to be minus e to the x. When I multiply negative 1 times e to the x, just minus e to the x, and then plus c. After that I'm done, I just put my plus c, and that's my answer. Same answer that I got on the previous one, but like I said, just a different way of looking at things. Now, in this case, it didn't save us much time. Let's look at another example where it will save us some time. For instance, the integral of x squared sine of 4x. So this one, if you use the other method, you would have to use integration by parts 2 times, which I know a lot of people enjoy because, that's double the fun. But some people would rather save some time and do it this way. So let's make our chart. So we have the sine, we have u, we have dv. So again, sine always starts positive, and u is what kind of determines how far this chart goes. So you start, my u is x squared, just like it would have been before. Let u be something that reduces, unless you're in that natural log case. And let me state right now, the natural log case doesn't work with this the tabular method. It doesn't work. So you have to use the other method that I showed in the other video. Okay? Do not use this for when you're dealing with natural log. It won't work out. And we have sine of 4x is our dv. Alright? So let me just go ahead and go through u until I get down to 0. So it's going to be 2x, it's going to be 2, and then 0. So then I'll fill in the rest of my dv's here. So the antiderivative of sine 4x. So I've talked about a little bit about that reverse chain rule, how the antiderivative of sine is negative cosine. Since the derivative of this inner function 4x is just 4, just a number, you can then just divide by 4, instead of having to use u sub. What you could do, you could use u sub on this if you're having a tough time. So it's negative 1/4 cosine 4x. Do my antiderivative of this one. So antiderivative of cosine is just sine. Again, I have to divide by 4. So it would be negative 1/16 sine of 4x. Do my antiderivative one more time to get, let's see, your antiderivative of sine is negative cosine, so it will be 1/64 cosine of 4x. I hope that you can read this. I know I'm writing a little small here to fit everything in. but I am saying it at the same time, so hopefully you're getting this. So this is going to be, then our signs just alternate. It always starts with positive, then it's go negative, plus, negative, and then I don't have to go anymore. So then I start from here, and go across, and down. Across, and down. Across, and down. And I'm at the end of my DVs, so that's when I know it's time to stop. So now what I will do is I'll do a plus x squared times negative 1/4 cosine 4x. And so I'll end up with negative 1/4 x squared cosine of 4x. Then I'll do a minus 2x times minus 1/16 sine of 4x. Notice I have two negatives, they'll cancel, so it'll actually be a plus 2x. Let me see here, I guess I could simplify, right? Because I have a 2 and a 1/16, so that'll simplify to a 1/8. So it'll be 1/8 x sine of 4x. Then I have a plus times a 2 times a 1/64, so it'll be positive. 2 over 64 is going to be 1 over 32. We'll simplify. Cosine 4x plus c. Let me take a quick peek, make sure that looks correct. And that looks correct. So yeah, so that's how you can use the tabular method. It's, I think it is easier when you have an x that is higher than just x. So if it's x squared, x cubed. So this will work great with something that's, x squared times sine of something, x cubed times cosine of something, x squared times e to the x, not x times ln x, or x to the third times ln x. Anything like that, you got to use the previous method, and it'll always end up being one step anyways. So you don't really need to even think of using the chart.